Hello, this is going to be lesson 8, solve equations with rational expressions. So basically, whenever you have an equation with rational expressions, what you want to do is get rid of the denominator. Okay? In order to get rid of the denominator, you need to find the common denominator. Okay? On a problem like this, basically I would ask, what number does 5, 2, and 10 go into? And the answer would be 10. So that means your least common denominator is going to be 10. If you also remember the way I taught you, you make a list of all the denominators. So in this case I have denominator 5, I have denominator 2, and number 10, if you do the prime factorization, 10 breaks down as 2 times 5, so the denominator here would be 5 times 2. So what is my least common denominator? It would be, there's a 5 and there's a 2. So you can also find the common denominator by using this process, because notice here the denominator would be 5 times 2, or in other words 10. So basically my common denominator is 10, so what I'm going to do is I'm going to multiply each term of this equation by 10. So I'm going to write 10 times 4x over 5 plus 10 times 3 over 2 equals 10 times 3x over 10. Now I'm going to do the multiplication. 5 cancels with the 10. 5 goes into 5 one time, 5 goes into 10 two times. So 2 times 4x is going to give me 8x. This one, I'm going to cancel the 2 with the 10. So this will become a 5. And 5 times 3 is 15. And the last one is going to be, the 10 cancels with the 10, you're left with 3x. And if you notice, I got rid of the fractions. And basically I have a very simple equation of where to solve. So the whole idea is, whenever you have an equation with fractions, find the least common denominator, multiply each term by the common denominator, and by doing that, you're going to get a new equation without fractions. So now all we have to do is solve for x, so I'm going to move the 3x to the other side. It becomes negative 3x. And the 15 I'm going to send to the other side, so it becomes negative 15. And 8x minus 3x is 5x equals negative 15 divided by 5. So that means x is equal to negative 3. And that will be my answer. Okay. Alright, let's go on to the example number 2. Alright, here's going to be example number 2. And this will be 3 over x minus x plus 21 over 3x equals to 5/3. Alright, very well. This one, I'm going to take my first denominator. I'm going to take my second denominator, which is, I'm going to line it up, right? So I have 3, and I have an x. And my third denominator, I only have a 3. So my LCD is going to be 3 and x. Alright, with that in mind, I'm going to multiply each term by 3x. So basically 3x times the first. And then, let me just move the, there we go. There we go. And I'm going to put a minus. I'm going to multiply by 3x. So this would be x plus 21 over 3x. And this would be 3x times 5/3. Now let's multiply each one of these terms. The x here cancels. So 3 times 3 is 9. Here the 3x is going to cancel. I'm left with a negative, so I need to apply the negative. to each term. So this would be negative x. Negative times a positive is a negative 21. And the 3 here is going to cancel with the 3, so I'm left with 5x. So now I have a very simple equation. All I have to do is combine like terms. So this would be negative x, negative 21 plus 9 is negative 12 equals 5x. Okay. And now we're going to solve for x. So let's go ahead and send the x to the other side. So this would be negative 12 equals 5x plus x. So this would be negative 12 equals 6x. And we divide both sides by 6. That means x equals negative 2. Okay. Now, one thing that we need to worry about when we have an equation of rational expressions is that whenever we have x's on the bottom, we need to determine what values of x is not valid. Because here we have an answer, negative 2. Is negative 2 going to be valid? Well, let's look at the numbers that would not be valid. Remember, whenever you have rational expressions, you need to be careful not to have a 0 on the denominator. So in this case, you have x and 3x. The only time that this denominator would become a 0 is if the x would equal 0. So the only value of x that it cannot be is 0. And since my answer is x equals negative 2, this is a valid answer. Okay, now if this answer had been x equals 0, this would not be a valid answer, then you would have no solution. But that's not the case in this case, okay? Alright, I'm just letting you know right there that every time you have x on the denominator, you need to check what are the valids. You need to check if your answer is a valid answer, okay? Alright, let's go on to the next example. So, let's do example number 3. And example number 3 is going to be x plus 6 over x minus 2 equals to 2 times x plus 2 x minus 2. Alright, if you notice here, we have first denominator x minus 2, second denominator is x minus 2, so that means our least common denominator is x minus 2. So in other words, I already have a common denominator, so basically all I have to do is multiply both sides by x minus 2, and when I do that, let's see here. Basically, they're going to cancel. This cancels with that. You're left with x plus 6. This one's going to cancel with that. You're left with 2 x plus 2. Alright, then it's a very simple equation where we can solve it. So first thing I'm going to do is just use the distributive property. And I'm going to get 2x plus 4. And then I'm going to move the x to the left and the 6 to the right. So this would be x minus 2x. And this would be 4 minus 6. On the left I get negative 1x. And on the right I get negative 2. To get the x alone, I'm going to divide by negative 1. X equals positive 2. Alright, so that's our answer here. Now we need to check if this is going to be a valid answer. Okay, if you notice your denominator, or at least the denominator here is x minus 2, or basically instead of looking over here, what you can do is just look at the least common denominator. And one of our denominator here is x minus 2, and we need to make sure that that cannot equal 0. So in other words, if we move the 2 to the other side, x cannot equals positive 2. And that happens to be the answer that we got. So that means this is not valid. Okay, the reason why it's not valid is because I plug it in a 2 right there. 2 minus 2 is 0. I cannot have a 0 on the denominator. So in other words, the answer for our problem here is no solution. Okay. Alright, let's go on to the next problem, example number 4. Alright, example number 4 is going to be 2x over 2x minus 1 plus 1 over x equals 1 over 2x minus 1. Okay. First order of business is to find your common denominator, so let's write the first denominator. The second denominator is going to be x, and the third denominator again is 2x minus 1. So therefore, our common denominator or LCD is 2x minus 1 and x. Alright, so with that in mind, we're going to multiply each one of these guys by our LCD. So I'm going to write x times 2x minus 1 multiply by the first fraction plus, again, x times 2x minus 1 times 1 over x, our second term, equals x times 2x minus 1 times the other fraction over here. Alright, now we're ready to do the multiplication. Now look at these. The 2x minus 1 is going to cancel, so x times 2x is 2x. The x here are going to cancel. 1 times 2x minus 1 is 2x minus 1. And in here, 2x minus 1 cancels. X times 1 is x. Now let's combine like terms. And I believe I did a mistake here. X times 2x is 2x squared. I'm sorry. Okay. Alright. Now that I made that correction, let's go ahead and write down 2x squared plus 2x minus 1. Let's bring the x to the other side. Alright, let's combine like terms. So this would be 2x squared plus x minus 1 equals 0. Alright, now our job is to try to factor. Okay, I asked those 3 questions. Can I factor anything from all 3 terms? And the answer in this problem would be no. Second question would be, can I use special factors? And the answer again would be no. So the last one I have to do is 2 times 1. 2 times 1 is 2. What numbers give me 2? 1 and 2. And would 1 and 2 give me a 1? Yes, it would if I put a positive here. And this would be a negative. And a positive times a negative gives me a negative, so that will work. So basically, I'm going to copy the 2x squared. I'm going to split the middle term as negative 1x plus 2x and bring down the negative 1. And then I'm going to group them. So I'm going to factor an x here, so this would be 2x minus 1. And here I'm going to factor out a 1, so this would be 2x minus 1 equals 0. And then, what do they have in common? They have in common 2x minus 1. And if I remove the 2x minus 1, I'm left with x plus 1 equals 0. So I have 2 possible answers. The 2 possible answers is going to be 2x minus 1 equals 0. And if I solve for x, move the 1 to the other side, it would be 2x equals 1 divided by 2. In other words, x equals 1/2. And here would be x plus 1 equals 0. X would be negative 1. So there's 2 possible answers here. Now let's look at the restrictions. the restrictions, you have to look over here. In other words, the numbers underneath the fractions, which are these guys, cannot equal 0. So in other words, I have 2x minus 1 cannot equal 0, and I have x cannot equal 0. So in this case here, this would be 2x must be different than 1 divided by 2. X must be different than 1/2. So if we notice here, one of our possible answers is 1/2, but this is part of the restriction. X cannot equals 1/2. So in other words, this is not valid. Okay. Now the other restriction is x cannot equal 0. There's nothing in the restriction that says -1. So that means my answer for this problem is going to be only the number -1, because 1/2 is prohibited. Okay. Also, I want you to point it out that you see here I have 2x minus 1 and here's 2x minus 1. So in fact, you don't really have to do all this. Basically, if you just see, when you come down to this answer here, and you see 2x minus 1, and you see, oh, this is part of the LCD, okay, this will be an invalid answer here. But we don't see x plus 1, so that means this is going to lead us into one of the answers for this problem. Okay? Alright, let's go ahead and go to example number 5. Okay. Alright, here we go. Example number 5. Example number 5 is going to be 2x x minus 3 plus 6 minus 2x over x squared minus 9 equals x and x plus 3. Alright, so I'm going to take my first denominator, which is x minus 3. My second denominator, if you remember, this is a special factor which can be factored as x minus 3, x plus 3. So that means my second denominator is x minus 3, x plus 3. And my last denominator is x plus 3. So when I look at all three denominators, I determine that my LCD is going to be x minus 3, x plus 3. So basically, this is what I'm going to multiply each one of these terms by. So let's go ahead and do x minus 3, x plus 3 times our first fraction here, which is 2x over x minus 3 plus this would be 6 minus 2x. Oops. Excuse me. First, your LCD, x minus 3, x plus 3, and now the fraction 6 minus 2x over. Go ahead and copy the factor form. So x minus 3, x plus 3 equals, again, x minus 3, x plus 3, and times the fraction. Alright. Now that we have all that, let's go ahead and cancel what we can. We can cancel these guys. So that means I'm left with 2x times, let's use distributive property here. 2x times x is 2x squared plus 6x. These two cancel with these two, so I'm left on top with 6 minus 2x. And on the other side, I'm left with x plus 3 cancels. Use distributive property, so this would be x squared minus 3x. Alright. Now we need to move everything to one side, so I get one side to be 0. So this would be 2x squared. 6 minus 2 is 4x plus 6. Then we move this guy over there, and this guy becomes a positive 3x. Alright, now let's combine like terms. So this would be x squared plus 7x plus 6. As I combine this guy, got x squared. These two got 7x. Bring down the 6. Alright. Now, I ask myself, can I factor anything from all three? The answer is no. Can I use special factors? No, I cannot. So I multiply 1 times 6 is 6. And then what numbers give me 6? 1 and 6, and 2 and 3. And that's it. And we're looking for the number 7. So which one will give me 7? It would be 1 and 6. 6 has to be positive, so 1 also have to be positive. Positive and positive give me a positive, so it's okay. So that means this will be x plus 1 and x plus 6. And if you notice here, none of these match the LCD. So that means these two are going to be valid answers. So this would be x plus 1 equals 0. Move the 1 to the other side, would be x equals negative 1. That's going to be one of my answers. And here will be x plus 6 equals 0. So x equals negative 6. And that's my other valid answer. So the answers for these problems, for this problem, is negative 1 and negative 6. Alright. Alright, let's go on to example number 6. Example number 6 is going to be x over 2x squared plus 3x minus 2 minus 1 over 2x equals 3x squared plus 2x. Alright, very well. First order of business is, let's go ahead and factor these guys. Okay, so basically I multiply 2 times 2 equals 4. So numbers give me 4 is 1 and 4 and 2 and 2. Which one is going to give me a 3? The 1 and 4. And the 4 have to be positive, and the 1 would have to be a negative. So that means this would be 2x squared minus 1x plus 4x minus 2. Combine let's pair them up. So we're going to factor an x, so this would be 2x minus 1. Here I'm going to factor out a 2, so this would be 2x minus 1. And what can be factored from both? This would be 2x minus 1, and this becomes x plus 2. So my first denominator, when I factor, that's the factors that I get. My second denominator, there's nothing really that I can factor. And my third one, I can factor out an x. So this becomes x plus 2. Alright, very well. Now let's do find our denominator. My first denominator is 2x minus 1, x plus 2. My second denominator, this is my first. My second denominator is going to be 2x. My third denominator is going to be x and x plus 2. Alright. Now, my LCD will be 2x minus 1, x plus 2. So that's my LCD. Okay. Now with that means I'm going to take each one of these terms and multiply by my LCD. So let's go ahead and do that. I'm going to do 2x minus 1, x plus 2. Copy the first fraction. Copy in the factor form. So this would be 2x minus 1, x plus 2. Put a minus, copy the LCD, Okay, the only thing is I think I'm going to run out of space here, but let's see what we can do. X plus 2, and this would be 1 over 2x. Okay, what I'm going to do is I'm going to erase this to give us space. So let me rewrite here what we did. We wrote the denominator the first, which is 2x minus 1, x plus 2. We wrote 2x. We also wrote x plus 2. And when we compare, the LCD was 2x minus 1, x plus 2. Alright. So now gives us space to write things down over here. So I did my LCD and I multiply by this. Now I'm going to do my LCD again. And I'm going to multiply by the last fraction on the other side here in its factor form. Alright. So basically, if you notice, I copy each one of these fractions, and in front of it I put the LCD. Once I do that, then I'm going to do my multiplication, which basically here, these cancel, and I'm left with 2x times x, which is 2x squared. Then here, the 2x are going to cancel. Now here you need to be careful. There's a negative there, so I'm going to bring down the negative. And there is two binomials here, which we're going to apply FOIL. So 2x times x is 2x squared. 2x times 2 is positive 4x. Negative 1 times x is negative 1x. So when you combine it, you're going to get positive 3x. And last times last would be negative 2. Notice that I put a parenthesis because this negative here is going to apply for everybody inside the parenthesis. So please make sure to put parentheses, otherwise you will not get the right answer. Last one over here. I'm going to cancel the x. I'm going to cancel the x plus 2. So I'm left with 2 times 3 is 6. 6 times 2x is 12x. And 6 times negative 1 is negative 6. Alright, let's continue. This would be 2x squared, negative 2x squared, negative 3x, positive 2 equals 12x minus 6. 2x squared cancels. Let's go ahead and bring those guys over. Actually, let's bring down the 12x, which will become negative 12x. And let's go ahead and send to the other side the positive 2. So this will be negative 6 minus 2. So this answer will be negative 15x equals positive 8. Divide both sides by 15. That means x equals negative 8 over 15. I'm sorry, this is a negative, so negative negative cancels. So this would be positive 8/15. Alright. Now we need to check if this is a valid answer. Okay, remember our LCD. This tells us that x cannot equal 0. This tells us that x will not be able to move the 1 to the other side, so it becomes positive 1. And then divide by 2. X cannot equals 1/2. And this last one, x cannot equal negative 2. Now, nowhere in here it says it cannot equals 8/15, so this is a valid answer. So the answer for this problem is 8/15. There we go. Alright. So this concludes the examples for this lesson. So go ahead and stop the video and go ahead and try your assignment problems. Thank you very much for your time and have a great day.